Okay, so in this video we're going to discuss the command grep, which stands for Global Regular Expression Print, and we're gonna describe what this command does, and we're also gonna make a very simple watered down version of the command in Python ourselves. Okay, so the grep command is used to basically take in data and filter the results. Okay, so I can say ls. Let's change directories to my home directory. ls. I have these different items, ls-l. So these are an individual listing of all of the items in my home directory. Okay. Now we learned that you can send data as standard input to another command using the pipe. So ls-l pipe, and then I can type grep. So again, grep is pattern matching. Okay, and we're going to match the pattern. Let's say I want to find all of the items in this folder that start with a capital P, right? So here, this is the result. The input was all of this, everything from the ls-l command, right? So this entire input, right? And what grep does is anything that matches this pattern, it's going to only print those lines. Okay, so here there's a capital P in PDF, pictures, and public, right? And the pattern can be any number of different things. And grep allows for a lot of different features we're not going to use in our version, but just to give you a gist of how this works, let's look at something. Let's see, what else can we have? It says anything with an ES at the end of it, right? ES. So that's desktop, pictures, and templates, right? It prints out those three items. All right, so that's essentially what it does. Now notice we are piping that data. So that means grep is collecting data on standard input, and it's not giving you a message for every single thing that you type, right? So if I were to just run grep by itself and look for ES, right? Now it's prompting me for standard input, right? But it doesn't give me any message. It doesn't give me any indication of what I'm supposed to type in. So if I type in bananas, press enter, nothing happens. If I type in apples, apples has an ES in it, and that's the pattern I'm trying to match. So as soon as I press enter, grep also prints that out. Okay, and it highlights, in the version I'm using, it highlights the pattern match, right? Now these two items, grep did not print those out. I explicitly typed those in my terminal and pressed enter. This is the one that grep printed out, and you can see that because of the red characters, right? So grep continues to do this with whatever you type here. So, if I type houses, right? This is the one that I typed in and press enter, and then grep read that in as standard input, and it saw that it matches the pattern, the ES pattern, and then it printed it out. And this continues indefinitely. I have to send the end of file signal, Control D, in order for grep to stop. So this is designed entirely to be used with piped in data, right? So it's not generally meant to be used with a TTY. It's not meant to be used interactively like this. Okay, you can run it and you see sort of what happens, but you have to know how to end the file or end the standard input using Control D. All right, so why is this command so useful? So let's take a look at a couple things why this might be useful. So if we run the PS command, this is going to show us process data for our operating system, what processes are being run, right? And these are processes for myself. Let's look at PS. We're going to look at all of the processes by username that are currently executing, and we get a much bigger list, right? And it tells you what user is executing these processes. We've got a lot of root. We've got different users, and most of these are system users. GDM and these different things are system users. They're not actually individual users. But we see there's a lot of things running on this computer, right? And it's sort of a lot to look through. So if I'm looking for something specific, so I want to run the ps aux command, and I want to look for, let's see, Firefox. I want to look to see if Firefox is running. So these are all the Firefox processes. So when you start up a Firefox browser, there's several processes that start up, and then each tab usually has its own process as well. Okay, so we can do the same thing with a number of different, let's just see if we have any Chrome tabs open. Okay, so it only shows one result for Chrome. That's because I don't have Chrome open. And look what this result is. This result is me running the grep command searching for Chrome. So that was a process. The pattern, Chrome, matches itself, right? So when we looked at PSAUX and searched for Chrome, Chrome wasn't running, but the grep command was searching for Chrome. So that's why this one came up. All right. So there's a lot of things we can look for. If I want to look for a particular user, I want to see what all processes the root user is running, right? So here we see matches root all the way up here. And here this last one is user Luke, but this is the same thing. The grep command matched its search for root. Okay, so these are all the root processes. So that sort of thing. So this is very useful for filtering out unnecessary data. Right? So you have a large data set and you want to find specific things. Right? How else can this be used? So this is an example of running a command and then piping that data. Right? We could also send the data in from a file. Right? So if I have grep and I want to see who's using the ZSH shell in the password file, right? So I can say cat/etc passwd. This is the password file. It doesn't actually contain passwords. It used to contain hash passwords, but it's all handled differently in Linux now. But that's why it's called the password file. It doesn't hold those anymore. So if I print this out, this is an example of all the users in the password file, and most of these are system users, right? We see down here we have Luke, that's my user, and then here we have user. This is just sort of a generic user, okay? And if we go ahead and let's see, run this again, cat etc password, right? But I want to search and see who's using this shell. Who's using /bin/zsh. So I can search for that. That's my pattern. /bin/zsh. Grep. There I go. All right, and so the result is these items. So these two users, user Luke and user, are using bin/zsh. Who's using the bash shell? Let's see. Alright, so the root user is still using bash, which is the default on this machine. Okay, so we can also do this from, instead of piping, right, we can run the grep command, and then as standard input, we can run /etc/passwd. And that's the same result, essentially. Right, if we want to search for ZSH. Okay, so this is just, if you want to get the input from a file, you can just use this syntax, right? Or you can cat the file and then pipe it, right? Two different ways of sort of doing the same thing. All right, what else can we do? So a good example would be most Linux distributions, you have /user/share, and then you have a dictionary of words. Alright, so let's see what's in this file. And it's just a whole bunch of different words. So this would be good for, let's say you're playing Scrabble with your friend, and you have a certain series of letters you want to try, right? So what I can do is I can pipe this to grep, and I can say I want to look for words that end in EST, right? And these are all the words that end in, or that have EST in them, right? So if you had an unusual list of letters, right? So something like I've got a Q and a U, and I want to look at all the different words that I can spell like this, but then you also have an S. All right, so you can, you want to pipe that to grep S. So you can do this multiple times. So these are all the words that have a Q and a U, and then also have an S, right? Or we can say the end in ism, right? Grep ism. There we go. So here's the words. They have a Q and a U, right? So that's from this command, right? And then the output of this command, we pipe to grep again. And so we see our list is getting shorter. Okay, so this is a very useful command. One other quick example is there's a command called rig. It's not installed by default on a lot of systems, but it stands for random identity generator. And if I just run this command, it creates some random identity that's not real. It's just fake names, fake data. And it's useful for testing programs and different things like that. So I can run rig, and I can use the -C command option and specify how many of these identities I want. So I could say I want 4 identities, and it prints out 4 of these random identities. All right, so let's say I have a big list of 3,000 identities, right? And I could print that out, and there are 3,000 of these. Well, what if I want to find out in this list how many of these people have the last name Smith? So in 3,000 entries, there were this many Smiths. If I run it again, all of the identities are different, so I'm not going to get these same exact results, but I can run it and see this time there were only 2 results. Okay, so let's say that I have a data file. Let's cd to our desktop, and I've got a data file here of 3,000 items, and I'm going to call this data.txt. All right, so we output the results of this rig command into data.txt, and I want to see cat data. I want to pipe that to grep, and let's see how many Smiths we have. Okay, there's just a couple there. Let's run it again until we get a few more Smiths. That's not doing it. It's up at 5,000. There we go. There we got more. Okay, so these are all the Smiths. But notice this only shows that one particular line that matched the pattern. Okay, so we can add to grep. There are options. So we can add context. So we can say, after you find the match, print out 4 more lines. So that's what this -A, capital A. So after you find a match, so whenever we see one of these matches, we want to print out 4 more lines of context after that. And then we're still going to search for Smith. Okay, so now here we see there's the match, and then we printed out 4 more lines, right? And this last line was a blank line, so we don't really need that last line. We could probably do 3. All right, so that's sort of the grep command, and it's extremely useful for sorting data, searching for data, looking through things. And you can look through file data, which is really nice, but you can, or you can execute a command and pipe the data in. Okay, so what we're going to do, we're not going to implement the -A style. The grep has a whole lot of different options. It's a really, really, really useful tool. I recommend you run the man grep and check out the manual on the grep command. It's very, very useful. But we're going to try to implement a very, very simple version of grep using Python. Okay, so let's take a look here. We've got our data file. We're going to make my grep. So let's create a new file. There we go, new file, and this is mygrep.py. Add a hashbang at the beginning to make this executable. We're going to change the mode. It makes it executable. Right. And now what we want to do is import sys. But basically we're going to be collecting data in a loop. And as we detect that data, we want to basically just as we detect lines, we print that out, right? So we can start with a loop while true, and we can say sys.readLine. And sorry, that's sys.stdin.readLine. All right, so this is going to read in one single line of data, and we also want to get in some arguments, right? So our command has to take in one argument. That's the pattern, right? So sys.argv is the argument vector, so that's the list of the arguments the command takes in. So we can start out by just printing that. What does sys.argv give us? And then we'll comment this out real quick. We'll start simple. So I can run the program, my grep, and I pass in a pattern. So this pattern, right, we'd be looking for Smith, right? So the argument vector starts out with the name of the program as the first argument, and then any arguments you provide it, right? So any arguments after running the command are added to this list. Now we don't really need this first item. So usually what I do with the argument vector is I make a separate args variable and I slice off that first item. Right? So this makes a new list, and the new list consists of everything from sys.argv, but we start after the first item. So we start at the number 1 slice and go all the way to the end. Right? And then we can print out args, and so this will give us args without the file name. Right? Smith Bob James, right? So that works. So what that means is that our pattern then is going to be args 0, that first item, right? And then we can print out pattern. Okay, so just like with grep, we say we run our command, mygrep, and then we pass in a pattern. And so Smith is our pattern. So that's good. We've got our pattern. Right? Now what we want to do is read in data from standard input. Right? So we'll do this on a loop. Right? While true, get line from standard in, read line. And then we can print that line. Let's print out line. So everything here is going to be echoed. So whatever I type is echoed, right? With an additional new line character, or yeah, the print statement adds a new line character, right? So what if I want to stop entering data, right? This doesn't work. I have to use a keyboard interrupt, right? Control C. Right, so instead of this while loop, I can just read all of the data in. So this is all of the data, stdin.read, and I can split that over all the new line characters. Actually, so this is just one big long string that contains all of the standard input, including the return characters, including the new line characters. So I'm just going to call this data because this is just one string, and then this is going to be the individual lines. This is going to be a list of the individual lines. So I'm going to say data.split over the new line character. Right? And so this should be a list of all of the data. Alright, so let's try this. Now I can type in something, apples, bananas, and as soon as I'm done, I would send the end of file signal, Control D, and we get this list of data here. All right, and we might want to remove an item if we have an extra new line character or not. All right, but we see that that's working. All right, so now what we want to do is iterate over this list of data for line in our list of lines. So notice the plural. This is a list. This is plural because there's multiple items in our list. So whenever you see something pluralized, that's either a list of items or an object, a dictionary of items in most cases. So here we're iterating, and this variable line is going to be one of those lines each time through the loop. Right, so this would be us printing them out one at a time. We print out line, right? But in this case, we want each line, but we only want to print the line if it matches our pattern. So if our pattern is in that line, right? So this is checking to see if this string is a substring of line. That's what the in operator does in Python. So if our pattern, so if this is Smith, is in this line, which could be somebody else's name, we're going to go ahead and print that line out. All right, so let's make our pattern ES, and then apples, and then bananas, and then Control D. All right, so we see that apples matches the pattern, so it was printed out. So again, grep is not meant to be used in interactive mode like this, so let's pipe it some data. So let's say echo apples, new line character, bananas, and then grapes, and then oranges. Alright, so this is the data. We're going to pipe it to my grep, and we're going to see which ones match the ES. So of all these items, banana did not match. Right, so it's not output. So we've essentially just mimicked grep in its simplest form. We get all of this data from standard input, and in this case it's being piped. Right? I could also echo or redirect that output to fruits.txt, and so then I could run my grep, and we could look for let's see, RA, anything that has RA in it, and our input will be fruits. And so grapes have RA, and so do oranges. Right? So this is an example of very simple pattern matching, and we're using standard in without using the input function. So in Python we're used to interacting with the TTY in this way. With a lot of programs don't necessarily interact in that way, grep being one of them, and it's one of the most useful programs there is. Okay, so look into grep, learn more about it. It's an excellent tool, and play around with this. Try to code this up yourself from scratch. The more practice you have doing these sorts of things, mimicking other programs, even if it's just a small subset of their functionality, it's a very useful thing to do. All right, so that should do it for this one.